Ladies and gentlemen, Joey Geiger talking about Conmango. I don't know, I can't pronounce it, he can though.
It's actually Conmango. It's a connection manager written in Go. I guess the other part of this talk is dealing with a self-created zombie horde. Who am I? My name is Joey Geiger. As you said, I work for Nexia Home Intelligence. We're actually located in Broomfield. We do essentially personal home automation. You buy the devices, we supply you with a hub, and we can automate your lights, locks, thermostats, sensors, water sensors, things like that. What is Conman? Essentially, it is a proxy that accepts TCP connections from thermostats, passes those messages from the thermostats onto a processing application, and then passes commands from that application back to the thermostat. The message formats that we have are SMILE, which is SM, the single text or encoded binary, a couple of examples there, or faceplate, which is a proto-rough binary. We're actually transferring everything over to faceplate just because it is much less chatty. Currently, the SMILE thermostats, actually the one I have here is going to talk, and you can just see how many messages are being sent back and forth. The current existing workflow diagram is we have a bunch of thermostats that are making TCP connections via DNS round robin to a series of conman servers. The conman then passes messages to Redis. Redis then holds messages that the processors pull off, and then they eventually push further messages into Elasticache. Current performance is actually, it's written in Ruby. It handles about 4,000 thermostats on a box with an average about 3,000. This is from probably about a couple months ago, so it's changed a little bit. And that's running on an EC2 instance, C3 2XL. We use 10 boxes for failover and for load balancing. We have about 30,000 existing thermostats. Again, that's kind of old. We're probably going to more than 100,000 or more. We're growing about 3,000 a month, which is kind of interesting because it's just going very, very fast. Why Go? It's supposedly very good at this type of thing. Easy deploys, you just compile it, SCP up, and then just restart the binary. And it's fun to code, at least it's not painful. This is the current Conmango diagram. It's thermostats, TCP connection again to a conman running in Go. I pulled out Redis and actually am using, I've replaced it with essentially a HTTP server. So now the message processors will be written a little bit to actually do HTTP requests from there. So realistically, the main thing about this is just pulling out Redis, because Redis actually was kind of a bottleneck for us. So the Go performance, a single box accepted 27,000 connections before failing. That was actually an EC2 C48XL. The Ruby message processors were essentially unable to keep up with the incoming message load, and that's why it fell over. It wasn't really using any processor at all in the Go version. Essentially 2,000 messages a second versus 30 workers. They just couldn't keep up, and you could watch the queue just grow to the point where it just fell over. So how does it work? Conman, we have an application context that I'm passing that shares the channels, the queue, the server accepts TCP connections, and the HTTP server processes requests. The thing that I'm actually replacing Redis with is something I wrote called QE. Essentially, it's locking queues with first in, first out processing. Queues are checked and unlocked every 15 seconds. It's very, very important that we actually get the messages in order. There's a lot of message queues out there that'll say we can get it more than once, and things like that. We have to get it one time in order, because if you set your temperature to 70 degrees, you set it to 60, and then you set it back to 70. If you set it 70, 70, 60, you're going to be at 60 degrees, not 70. So it's actually very important that it goes in the correct order. Have a live demo. So this is, let's see, run that. This is now the thermostat running. Got to run this. Oops. Run that. So that's the log for that. Run that. So what you can see is actually it says conman receive messages 1. One conman thermostat's 1. So it's actually received the messages from this thermostat. There's actually a 10-second delay below the messages that the Ruby thing is processing. It now just sent over 90 messages, and it'll slowly go over and just keep adding messages. If I actually change the temperature on this, there it is, good. And I raise it up a few degrees, you should actually see some messages now on the lower part start to scroll through. So now it just received a message saying the temperature changed. You can see like the received messages jumped from 90 to 104, and now it just periodically sends messages. So when you have 30,000 of these connected to a box, each one of them is sending messages every couple of seconds. So part of the plan is actually to rewrite the Ruby processors in Go so we don't actually fall over all the time. Let's see. That is generally it. So thank you. Again, work for Nexia Home Intelligence. All right.
Just wondering what challenges you had in going from Ruby to Go.
Trying to convince our business to use it. We're actually still not in production. I'm trying to explain. I guess we're having issues whether we want to use that. We want to use Erlang, Elixir, something like that. The original thing was written in Ruby. It fell over because we thought it was an issue with Rabbit. So we had another company about a couple of years ago rewrite it in Elixir. They never actually got it working. So we went back and put it into Ruby use event machine. And that's what's actually currently running in production. But just on my off time, I was like, I want to rewrite this in Go and just kind of say, hey, this is a proof of concept. Will it work? And I was actually able one day when production was being redeployed for some other reason to just shut down everything else, bring this up, and test it just to see what it could actually handle. And it worked really well. And I really hope to get it further things into production just because of the performance.
Cool. Thanks.
Yep.
All right, everyone give a big round of applause for Joey. Thank you.
Thank you.